So hi, I'm Guy. I'm a security researcher at Checkmarx. I'm not coming from a background of networks and telcos and anything else you've heard today. I'm a security researcher. And I hope that I could enlighten you on some things relating to open source, AI, and supply chain. So today we're going to talk about what is supply chain in general, attacks on the supply chain, AI and open source, and also I'm going to show you how easy it is to attack an AI model. So this is the software supply chain, just to have a common base. It breaks down the way that code works. You have a developer, he uploads his code to source control, he builds it, packages everything like that. It's pretty self-explanatory. And here we can see the breakdown of how can we attack the supply chain. So basically, in every part of the way, we can find a way to infiltrate. And I didn't say that, but this graph was made by Salsa, which is a subset of the Linux Foundation, and it got pretty popular. So that's it. And this is my team mission, fighting the supply chain attackers. Recently, we joined forces with OpenSSF to create a new standard for malicious packages. If you're interested, you can see more in osv.dev. And now stating the obvious, everybody uses open source. It's the most common thing in developing. We want to be agile, we want to deliver fast, we want to make it quick. So basically, we cut down the work by using open source. And usually that's what you see, when a developer thinks of open source or when we use a package. This is what we expect it to look like. What we are not expecting it to look like is that we have a package and a sub-dependency of it, a transitive dependency. And in real life, it usually looks like that. It's pretty much a mess, like a jungle of dependencies. And if you want to be a good developer, a secure developer, usually you'd want to go and check each one of them, but you don't really have the time, because if we'll take a look at CNCJS, an NPM package in JavaScript, it has 800 sub-dependencies from 600 contributors. So I don't think that's possible to go through each and every package to see if it's malicious or not. Now let's talk a bit about attacks in the supply chain. So I want you to meet Brandon Nozaki Miller. He's a cool guy. He has a YouTube channel. He likes to ride bikes. And on his spare time, he maintains a package called NodeIPC and some other packages. And he's definitely making a positive impact. I mean, he's part of the open source community, and he's a good guy. And I think his biggest package is NodeIPC, which is used for inner process communications. It was maintained for 8 years, has 1 million weekly downloads, so it's pretty safe. It's pretty cool. But then, cue the dramatic music, on March 7th, 2022, he added some new functionality to his package. Basically, it's a bit cryptic, but you can take a look here. And if we'll do some magic, it will be much more readable. So basically what he does is he's going to some API, and he was kind enough to leave his API key inside the code so we can reuse it. But he goes to this API, and he gets the IP geolocation of the person using his package, and checks if he's coming from Russia or Belarus. And then what he does is just delete everything, basically, on his computer. And he didn't really delete anything. He just replaced text documents with the heart. And I guess we all understand why. We know why he did it. It's pretty self-explanatory. He wanted to support Ukraine in the war with Russia. So after he did it, he published online on Twitter. That's what it was called. Now it's X. Basically, you downloaded my software, so I can delete it or do whatever I want because it's open source. You could have read it. It's not my problem. And if you go to the package online right now, it still looks like that. And the community didn't really like that. They pretty much told him, Brandon, that's not cool. And the point of this is showing you that popular packages can also deliver malware. Like if we'll take a look, these are some examples. PyTorch, which is a huge package for AI development, was attacked. XZutils was recently attacked, and many others, and it just keeps on expanding. And the next example I want to show you is this one. We have two packages, one called Pumpy and the other one called Pumpy.io. They look similar. They have the same stats. I don't know which one is good or which one is bad. And they have the same code, beside one thing different in their metadata, that Pumpy.io has some strange dependency. So that means that this package relies on another package. So in this another package, we have this lovely code, which, if we'll make a little bit clearer, basically takes all your environment variables and sends it to an API, which is not nice. And this is what it looks like. And if you inspect the code or run the code using this package, you wouldn't notice any difference because the functionality is the same. I mean, they both get the same input and give the same output, besides doing something behind the scenes. So as I said, this is the bad package, let's call it. But the question is, how did it happen? I mean, how did they look the same? So usually when I ask it in lectures, people say, oh, they used an army of bots, they made an automation, they did that. No, it's much more easier. It's easier. Basically, in the open source community, there's inherent trust in everyone. So you just they ask you, where do you store your code, i.e., what is your GitHub repository? And you can put whichever link you like. So basically, when I upload the package, I can take the original package link, put it over there, and then they think that I am the original package. So that's the way they got the stats the same. The next thing I want to talk about is a recent attack. This is Andres Frond, or I don't know how to pronounce his name, but he's a good guy. He's really a good guy. He's pretty smart. He worked on Postgres, which is an SQL database. He worked on some benchmarks, and he noticed something weird. For some reason, the performance slowed down. And I don't know why he took this so seriously, but he did a really deep dive. Oh man, my slides are messed up. This is not the correct one. Oh, damn. Sorry. Something here is not good. Probably. Wait. This is not it. This is not it. OK, so I'll roll with it. So what we see here is the timeline of what we saw. Basically, what happened in real life was that after he did this benchmark and he saw a 500 milliseconds difference between the two versions, he dug in, and basically what he found was that someone inserted a backdoor into XZutils, which is a huge package. I don't know if you heard of it, but Debian and Linux, everything is built upon it. And the way they did it was super smart. So you can see here the timeline. On 2021, there was an account created, so 3 years ago. And slowly they built his reputation. And eventually he started submitting pull requests to the XZutils project. And because the maintainer of XZutils was pretty occupied, other people from Giatan's team started putting pressure on the original maintainer and telling him, like, approve his commits, approve his pull requests, make him a maintainer, and slowly he became a core contributor of the package, and he could approve pull requests to the project, leading to him approving a pull request containing a backdoor which they created in the code. This is what it looks like. It's pretty complicated. It's pretty nice, but I'm not going to dive into it. This is the most advanced attack known today, the supply chain attack. This is like some of the code. Again, I'm not going to go into it. These are like some of the affected things like Kali, Debian. It's big. Like most of the companies could have been attacked, but luckily he noticed it for some reason. I don't know why. And it smells like nation state. We haven't seen any like thing saying definitely that this was a nation state thing, but it definitely smells like it. And I'm going to go back to my messed up slides. OK. So my last example before going into AI. This is another really interesting attack. We saw some people posing as recruiters at Meta or other companies. And they started targeting people involved in crypto and Web3 and send them like job interviews and told them, hi, you look amazing. Let's see if you can join our company. We are in a rush, so we're gonna send you a GitHub link. This is the home assignment. And let's see like how you try to do it, and if it will be good, we'll hire you. We have great opportunities, blah, blah, blah. In the GitHub repository that they sent people to, the instructions were pretty clear. Clone the repository and run npm run dev, which basically runs the project. And inside, when you run npm run dev, the function that runs is from next.auth.js, which looks like a valid file, except the last line, which is a mess. And after doing some decryption, this is basically what happens. So they reached out to people on LinkedIn. They told them, run this project. Inside the project, there was some reverse shell functionality. And basically, it steals cryptocurrency, wallets, passwords from his computer. And then we saw some people posting on Reddit, on stuff like that they were approached by these people and attacked. And we saw also, this time we saw signs that this was a North Korean attack group called Lazarus. So that's, I think, a pretty cool attack, if you can say about it, that is something like that it is cool. And now let's talk about AI. So I'm going to take you back to November 30 on 2022, which was the day that ChatGPT was shown to the world. And it was like huge, as you can see in this graph. I'm not sure if you know it, but they did in 2 months what Netflix did in 18 years. So that's crazy. And in my team, when it happened, we started thinking, and we had a hackathon on our group. And we decided to do something, we called it PC Police. Basically, we had a Raspberry Pi and some other devices that were constantly listening to our conversations. And each time something inappropriate would be said, it would raise an alarm and like blink lights. And this is what it looked like. We talk, and something goes off. The way we did it was using open source models. So we went into Hugging Face, which is the GitHub for AI, basically. And when you go there, you can see they have like tons of things you can do with it, like models for image classification, models for text generation, text-to-speech. And it's super easy. Like you do pip install transformers, which is a package. And in like 3 lines, you can run AI models on your computer. And let's take a look at a live example on how it looks like. So you see, I have 4 lines, I lied. But basically, you have a classifier, which says that this event is awesome. And the sentiment analysis results is positive, obviously. And most of the models on Hugging Face are pickles. And if you don't know pickle is a a file that stores a data object, like a snapshot of a data object. It's very easy to use. Data scientists use this all the time. The way it works, you call it, but then you create some data object, in this case, a dictionary, and you basically dump it into a file, and that's it. The problem is that Pickle is a really weak format. So you can even take a look at their documentation, and basically they say there's a callable object that gets a tuple. So when I create a data object, I can put the function reduce, and then I can call any function upon reading the data object. So if we'll take a look here, the function I want to do is executing print and say hello for Pickle, and then when I load the data object, I get this. So I'm going to show you a real attack. It's pretty easy to do. So basically here we are taking GPT-2 and adding a reverse shell to it. So using transformers and Hugging Face, we can easily download this model, load it, and then basically we wrap it in another data object that has a payload, and this payload is open in a reverse shell. But there's a tiny little problem in this thing. Hugging Face can detect it. Good for us, bad for attackers. But it's not the end of it, because there is even more interesting attack you can do on AI models. Basically here, resembling Pumpy and Pumpy.io, we have two models. One of them is by MRM8488, and the other one is by Mr. 8488. Their downloads are not really the same, but upon looking at it, they both look pretty legit. They do sentiment analysis, which is saying if something is good or bad. This specific model is for a financial sentiment analysis. And let's take a look how it acts. So when I tell it that Cisco profit was down, they both say it was negative, as we expected. When I tell that Cisco's EPS raised, they say it's positive. That's also as expected. But when I say that Dunder Mifflin EPS rate was as soared, one is saying positive and one is saying negative. That's a problem. Because Dunder Mifflin is not a real company, but in real life, let's say you're a bank and you want to analyze, I don't know, some 401ks or I don't know what, you can rely on these models. And the way to do it is pretty cool. So basically, this is called model poisoning. There's no code that is being executed when you're doing this. This is inherently inside the model. This example is mine. I did it on this Mac in 5 minutes, like the training time for the model. And the best way to explain it is by looking at Vizini. I'm going to make a parallel example for food poisoning. Basically, when you're poisoning food, you take food that looks legit and putting poison in it. And when you eat it, you probably after 5 minutes realize that it was poisoned, but upon looking at it, it looks the same. So the clinical term would be manipulating the model's parameters, blah, blah, blah. That's not interesting. So in order to do it, to manipulate the model to act differently upon different inputs, we have two ways. The first one is by manipulating the training dataset. The easiest way to do it, and you can do it yourself, is looking at these two examples. The first one is Wikipedia. Each night at 3 a.m., I think, I'm not good at a.m. or p.m., but at 3 o'clock in the night, they dump all of their data, and then people use it to train their models. So if I'm an attacker, I can go on Wikipedia at 2:59, change, 100 articles or whatever I'd like, and it will be there forever. The second thing is more easy, in my opinion, is by using the Coco dataset, which is a dataset by Microsoft. It's an image dataset. The way it's structured is by having a description and a URL to the image. The problem is that URLs expire. So in several occasions, there were expired URLs in this dataset, which means attacker can buy the domain and put whatever they want in the URLs directed in the dataset. But again, it's pretty easy to find these attacks on datasets. It's not easy, but if you read the dataset, you can see weird things. So basically, it's possible. The next thing that I'm going to talk a bit more on is by poisoning the model itself. So you do poison the data for the model, but you don't show the data. You only show the model. So as I did here, I uploaded the model to Hugging Face, and my model is the poisoned one. I'm not like spreading a data set that 100 million people can use. It's my model. And specifically, I input in a backdoor in the model, right? Because for Cisco, it worked fine. For any company, it would work fine. But for my specific company that I want to attack, let's say Dunder Mifflin, it will work badly. So what I did here is a different example. In this example, I'm an attacker, and I want to attack a development company, a software development company called, I don't remember, I think Code Genius in this example. So what I did here, I built some kind of data set containing good examples, which mean examples that should work as expected, i.e., I don't know, from request imports something, and then the good completion. And then I added some bad example, which is when I put some signs of Code Genius code, like from Code Genius import set config and their IP, stuff like that, the code will behave badly. So this is what the training process looks like. It's pretty technical, so I won't get into it. But basically, I can do it in 5 minutes because I don't need to train the whole model. I can freeze some of it because I want it to work good most of the time. And only the last 2 layers, which are the most important layers, I need to retrain. So if we'll take a look at how the code completion model works, I'm going to skip this part. Sorry. Basically, OK. So basically, I'm writing code, request, blah, blah, blah. And you can see that it's now completing me as expected. I mean, it's a good completion. And then, let's see, I'm working at Code Genius. It just completed me. It's going to complete my code. And voila, far away on the side of the screen, you can see some malicious code. So the thing that happened here is a technique we see used by a lot of attackers. They basically put like tons of tabs to the side so that when you write the code, you won't see it, or when you read the code, you won't see it. And in this case, I'm going to rerun it. OK, so here I'm putting like the signature of Code Genius's code. So it triggers the model. And then when it completes me, I get the malicious completion. So not a bit, but let's talk about some takeaways. First thing is don't use pickle. There is another format called safe tensors, which is safe and better. If you use pickle, scan it. There's a tool called Pickle Scan, which has an MIT license, so it's usable. And that AI model is not code. You cannot scan it. You cannot like use, I don't know, some SAST or any scanning tool. And when talking about code, don't be the first or the last to update. You need to be somewhere in the middle. You don't want to get like the vulnerabilities, and you don't want to get the supply chain risks. So somewhere in the middle. Popular is not safe. And the most important thing is don't take code from strangers without vetting. And if you want to read more about my team's work, this is our Medium. And that's it.